Hi everyone. So in this session, we will discuss weekly quiz 2 questions. Did you attempt it? I can see that this weekly quiz 2, this was attempted by more than 100 students within the first day. Okay, like within 24 hours, more than 100 students attempted this weekly quiz. So that's a big thing, right? So if you have attempted this weekly quiz, then definitely you must have enjoyed the questions. I think there was no mistake there. There was one small mistake, but that was corrected. Okay, and many students got, I think, more than 10 marks, more than 12 marks. Some students got 15 out of 15. Okay, but most of the students, many students, they got more than 10 marks. Okay, and that is a good thing. Also, let me tell you one thing, that marks do not matter. How many marks you are getting, that does not matter. The only thing matters is after the weekly quiz, you analyze the weekly quiz, you analyze your mistakes, and did you learn something from it? Can anyone tell me? Like those students who have analyzed the weekly quiz, okay, all the 10 questions, you did the analysis. After the analysis, did you learn something new? Something like, can you say that you improved? Your knowledge improved? Okay, that is the important part. Okay, that is the target, that is the purpose of weekly quiz. Okay, so let's start the weekly quiz solution. Weekly quiz 2. In this weekly quiz, all the questions were from the proof techniques. Okay, there were 10 questions, and all these questions we have already seen. Let me tell you, to solve these questions, every concept we have already seen in our course, in our lectures. So let's see the solutions now. Let's start with this question, the most popular question of this weekly quiz. Many people were discussing this question, and uh, this question was also in the homework. Correct? I told you that this is my favorite question, one of my favorite question. I told you, and you already know, knew that this question will come in the weekly quiz, right? Yes or no? So in the homework we have already seen the solution of this question. But the only thing I did, I changed the options. And in these options also, many students made the mistake. See, this same question we have already seen in the homework. The only change I made was in the options. Options I changed. Still, many students made many mistakes. Okay, so let's discuss. First of all, let's discuss this question. This actually we have already seen. Let me tell you that what the question is saying. Read the question carefully. The question is saying that there is a right angle triangle in which all the sides are integers. Okay, so you can easily see that in this all the sides are integers. This is the point. This is the first point to consider. Okay, so you note that all the sides are integers. So this is a this is a right angle triangle. This is your triangle, and in this triangle you can see that this is A, this is B, this is C, this is the 90-degree angle. And the question is saying that A, B, C all are integers. This is an important point, that these are integers. This is given to you that all the sides are integers. Now, do you remember we have already seen in the homework that in any right angle triangle, if all the sides are integers, then one of them will be definitely even. At least one of them will be definitely even. This point we have already seen, if you remember. In which homework this question was there? I think in the homework 2. Tell me, in the homework 2, right? Okay. So in the homework 2, if you remember, this question we have already seen, the solution we have seen, the video solution we have seen. And I told you that in any right angle triangle, in any right angle triangle, if all sides are integers, this we have seen that if all sides are integers, then you can notice one of the shorter side will be even. At least one of the shorter side will be even. At least one of the two shorter sides. Okay, so I can say at least one of the two shorter sides is always even. Okay, this point we have already seen. At least one of them will always be even. Okay, at least one of the two shorter sides will be always even. So you can easily see if these are integers, this is the final conclusion. This is A, this is B, this is C. This is the longest side. This is the longest side of this triangle. And you know that because this is a right angle triangle, so we have this equation: a square plus b square is equal to c square. This is your favorite equation. And I told you that if a comma b comma c are integers, if these are integers, then what is going to happen? Then at least a comma b, okay, then either a or b will be even. At least one of a comma b will be even. At least one of a comma b is necessarily even. At least one of them will be even. Okay, very simple point. At least one of them will definitely be even. And the same statement, do you remember? We can also say like this, that this is never possible. Odd square plus odd square, odd square plus odd square. This can never be equal to what? This can never be equal to any integer's whole square. Okay, correct? Do you remember? I told you that odd square plus odd square, this is never equal to any integer's whole square. Any integer, you can put any integer you can put here. So odd square plus odd square can never be perfect square. So you can also say that summation of two odd squares, summation of two odd squares is never a perfect square. Is never a perfect square. See, all these points we have already seen, if you remember, in the homework too, as I told you. So please understand that if you did not watch this session, we have done the video solution of homework too. We have done the live discussion of homework too. In this homework too, this question we already have. And I told you all these points, that if you have a right angle triangle, this is a right angle triangle. In this right angle triangle, if all sides are integers, if this happens, then one of these two sides, at least one of these two sides, okay, at least one of them, please understand, at least one of them will be always even. The same statement you can write in a different way. You can write like this, that odd square plus odd square can never be integer square. I can say summation of two odd squares is never a perfect square. It is never a perfect square. Very simple. Now you can easily see in this question, you know that a comma b is even. This information you have. Can you give some other information? Can you say anything about C? Tell me. Like, can you say anything about C? This is your triangle. This is A, this is B, and this is C. This is 90 degree. A comma B comma C are integers. Now you tell me what we can say. This we can say that A or B is even. We know that this we can say definitely one of them is even. But can you say anything about C? Can you say C is odd or even? We cannot say anything. Remember, please understand that C can be anything. C can be even or odd. For example, if you take this situation, then C is you can consider this situation. Let me give you example number 1. You can consider that you can take A equal to 3, B equal to 4, then C equal to 5. So here you can see that C is odd. Okay, similarly, you can take an example 2. Example 2, that A is 6, B is 8, then C will be 10. So here you can see that C is even. So C can be anything. Also, can you notice that can both A comma B be even? Is it possible that both A comma B are even? Is it possible? Yes, it is possible. So both may be even, or you can see one of them can be odd. I hope all these points are clear. See, at least one of them will be even. You can notice at least one of them is even. At least one of them is even. Whatever you do, at least one of them will be even. C can be even or odd. C can be anything. Similarly, okay, both can be even. A comma B, both can be even. It is possible that both can be even, but it is not necessary that both are even. So A comma B is even. This is correct. Can I say A comma B both are even? Both even? This is not necessarily correct. A comma B both even. This is not necessary. This is not necessary. Okay, so you cannot say, please understand, you cannot say that both will be even. because this is not necessary that both are even. You can consider this counter example. Here you can notice A is odd, B is even. So this is not necessary that both are even. Okay. Now, but still it is correct. No, this is not correct. You tell me, let me ask you one question, Twinkle, you tell me, which is correct? One question I am asking, and you tell me which is correct. Okay. Simple question I am asking. You tell me, A plus B equal to B plus A. A plus B equal to B plus A. Let's assume these are integers. Okay, these are integers. Now you tell me which statement is correct. 2A is A square. Tell me which of them is correct. Let me know. Anyone? Which statement is correct? I am asking which is correct statement. Which of these correct statement? A, B are integers. Let me know. So now you can see. Okay, tell me. So you can see. Array, no. What may be? I am asking which is correct. See, you are doing a lot of overthinking. If you go back to your 10th class, you can say that this is correct, this is false. If you go back to your 10th class, you are doing a lot of overthinking. If you are saying that, okay, so see, very simple. The question is asking, I am asking which is correct. I am asking which is correct. Yes, this is correct. But remember, this is not correct. This is not correct. Okay, this is not correct. First, you say that this is not correct. Then you say that, yes, this may or may not be. First, you say this is not correct, right? This, because I am asking which is correct. This is my question. I am asking which statement is correct. You know that first statement is correct. You know second statement is not correct. But remember, second statement can be correct. Second statement, it's not like never. Second statement may or may not be correct. But the point is, because of this may or may not be, I can say that this statement is not correct. Is this point clear? Let me know. If you are thinking that this statement is correct, this statement is also correct, this statement is also correct, you are doing a lot of overthinking. Okay, a lot of overthinking you are doing, because just go to your 11th class, 10th class. Just imagine, okay, go back 1 month, 2 months, or maybe 1 year. Go back 1 year. If someone asks you randomly which is correct, then what you will say? You will say that first statement is correct. A plus B equal to B plus A. And you will say that second statement is not correct. In your mind, you have that yes, second statement is correct for A equal to 2. If A equal to 2, if you put A equal to 2, then second statement is correct. But second statement is not correct if you put A equal to 3. So for A equal to 2, it is correct. For A equal to 3, it is not correct. Ultimately, I can say that this statement is not correct. When you say that a statement is correct, it should always be correct. Is this clear? Let me know. When you say that a theorem is correct, it should always be correct. Very simple. If you say that, if you say that a statement, some statement, let's assume some statement S is correct, or I can say true or correct, then what that means? Then S must always be correct. S must be always correct. S must be necessarily correct. Okay. Is this clear? Very simple. Now let's move on. So in this, you can see very easily, you can see that. So A, B, A or B is correct. So definitely this is multiplication. Some students have done this mistake that they were thinking A, B, C. No, this is not A, B, C. This is multiplication ABC. Is this clear? Please understand. This is multiplication ABC. ABC means this is multiplication ABC. A multiplied by B multiplied by C. So this is multiplication. This is not A, B, C. So this multiplication will be even. Yes, because one of them is even. Either A or B is even. Correct? So definitely this option is correct, because you can easily see that A or B is even. Either A or B is even. This we already know. Either this is even or this is even. At least one of them is even. At least one of them, A or B, is even. So if that is even, then even multiplied by anything is even. So this option A is definitely correct. Can you say option B is correct? Can you say option B is correct? BC is even? No, we cannot say. We cannot say. Why? For example, you can consider this situation. You can assume that A is 4, B is 3, C is 5. Now you can easily see that B multiplied by C is not correct. Okay, consider this situation. This situation you can consider. So we cannot say that BC is even. We cannot say B multiplied by C is even. We cannot say. Yes, this will be done because this is saying AB or AC is even. We know that this is always even. This is always even. This is definitely even. AB is definitely even because A or B is even. So automatically AB is always even. Okay. So because AB is even and this is or AB or AC is even. So definitely yes, AB is even. So this statement is correct. Both A comma B are even. This is wrong. Okay. So very simple. For this question, answer will be option A comma C. I hope this point is clear to everyone. Anyone has any doubt in this? Let me know. Let me know. Twinkle is asking, if the question has always true, then the confusion would not have arisen. But in the GATE exam, they will not give you always true. And you cannot challenge it. The question is already correct. Is this clear? The question has no mistake. In the GATE exam also, the same question will come. In the GATE exam also, the same question will come. The question is asking which is the correct statement. Okay, which of them is a correct statement? Simple. Now, let's move on. So, the correct statements are A comma C. Okay, let's move on now. Let's see the next question. This is another question. This is a GoClasses weekly quiz 2, question number 8. Let's see this. This is n is a positive integer. There are some students who missed it. There are some students who missed it. Okay. There are some students who missed it. Let me tell you, some students made silly mistake because of this. There was one student, I don't remember the name, but there was one student who did not read this line. This line is already given in the question, and this line you did not read. So this line will make a difference, of course. Now you can easily see which of the following statements is or are true. Now what you can say. So let's see one by one. What about the first statement? If m comma a are positive integers and m divides a power n, then m power n divides a power n. Very easily you can see that this is false. Very easily. This statement A, what this is saying? Remember, n is a positive integer. Z plus. This n, if you look at this n, this is a positive integer. This n is either, I can say, for example, it can be 1, it can be 2, it can be 3. So this is a positive integer. The second point, the option A, in the option A, what we are saying? We are saying that m comma a are also positive integers. These are also positive integers. This z plus means positive integers. Positive integers. And what are positive integers? 1, 2, 3, 4. These are the positive integers. 0 is not a positive integer. 0 is neither positive nor negative. Now the question is saying that if m divides a power n, then m power n divides a power n. And this statement is very simple. Easily you can see that this statement is wrong. Okay. What is the counter example you can give? This statement. This is a false statement. This is not correct. And you can easily disprove by counter example. Disprove by counter example. You can easily disprove it by counter example. What is the counter example you can create? See, easy counter example you can create. Like, for example, you can say that m is 4. Let's assume m is 4. Now you can take a you can take as 2, and you can take n as 5. Now you can easily see, if you take this situation, if you take this counter example, then what is happening? See, m divides a power n. M divides a power n. This is correct. Okay, 4 divides 30. This is correct. 4 divides 32. This is correct. But still you can notice that 4 power 5 does not divide. Remember, 4 power 5 does not divide 2 power 5. So this is a simple counter example that you can create. Okay. Is this clear? Very simple counter example you can create. So this is your option A. Option A is wrong. Okay. You can say that option A is not true. This option A is not true. Let's see the option B. This is interesting. The best option is basically option B. If P is prime, A is positive integer, and P divides A power n, then P power n divides A power n. In this option B, we are saying that P is a prime number. Okay, and the remaining things are same. A is a positive integer, A comma n, these are positive integers. And we are saying that if P divides A power n, then P power n will divide A power n. And this you can easily prove. Do you remember I told you something called Euclid lemma? We have already seen there is something called Euclid lemma. Do you remember that? I told you that this is a helpful result. Euclid's lemma. What was that? Euclid lemma says that if P prime, okay, if P divides AB, then either P divides A or P divides B. Correct? Where P is a prime number. Where this P, this is a prime number. So this is the point. Okay, right. Okay, so this is a point. I told you this point that if P divides AB, if prime P is a prime number, if prime number divides AB, then either P divides A or P divides B. Remember this statement is true. This statement is true. This is Euclid's lemma. This statement is true. But the general statement is not true. Agree? The general statement is not true. For example, if M is an integer, then this statement is not true, that M divides AB, then M divides A or M divides B. Remember this statement, actually this statement where M is integer, this statement is actually false. We have already seen this in the homework too. This statement is false. Okay, very simple. Now, after that, now you can easily see that. Now you can prove it. You can easily prove it. This, how will you prove it? Tell me. Very simple. See, P divides A power n, and n is a positive integer. So from this, can I say that P will divide A? It's like P divides A multiplied by A power n minus 1. Okay. So P is a prime number. So whatever you do, ultimately P, okay, see, you can just keep it open. You can just keep opening. Okay, what will happen? This, for example, let me give you one example, concrete example. Let me give you, like, let's assume n is 3. Let's assume n is 3. Then in this situation, what will happen? Then in this situation, this will happen, that P. So from here, what you can say? From here, you can say that either P divides A or P divides A square. Correct? Yes or no? See, let's assume that n is 3. Let's assume n is 3. Now what will happen? That P divides this multiplication. Then from Euclid lemma, the Euclid lemma says that if P divides AB, then P divides A or P divides B. So easily you can see that if P divides A square, then either this divides this or this divides this. But whatever you do, if you open this, let's assume this does not happen. Then can I say P will divide A? Can I say P will divide A? Yes. If you open it, P will divide A. So whatever you do, P will divide A. Are you getting my point? Let's assume this does not happen. Let's assume, because there is OR here. So let's assume this does not happen. If this does not happen, then what will happen? Then from here, you can say that P will divide A or P will divide A. P will divide A or P will divide A. So whatever you do, P will definitely divide A. Is this clear to everyone? That from this Euclid lemma, we are just applying the Euclid lemma, nothing else. This Euclid lemma we are applying. Whatever you do, P will definitely divide A. So this conclusion we can get that this P is a prime number if P divides A power n. Then from here you can easily say, using Euclid lemma, Using Euclid lemma, you can definitely say that P divides A. And now it is very simple. If P divides A, then what that means? That means A equal to Pk. Okay, where K is an integer. So A equal to Pk. And from here, you can easily see that A power n is equal to P power n, K power n. And that's it. That's it. So this is also integer. This is also integer. So you can easily see that P power n divides A power n. Okay. So P power n divides A power n because this K power n, that is a integer. Okay. So this is your definition. So this is your proof. This was actually a very simple question if you think about it. All you have to do, just apply the Euclid lemma. Right? Euclid lemma you have to apply. That's it. This is the only thing you have to do. Just apply the Euclid lemma. If a prime number divides AB, then either it will divide A or it will divide B. One of them it will happen. So definitely you can see that if P divides A power n, then P will definitely divide A. P will definitely divide A, and that's it. P will definitely divide A. So P power n will divide A power n. Easily you can do. Okay. So this statement is true. And the remaining two statements are very simple, correct? The remaining two statements. Like for example, if T is odd, then T power n is odd. If T is even, then T power n is even. But actually, let me tell you how to prove it. The next statement, if you look, the third statement, what the third statement is saying? It is saying that T is odd. Now, the question, and n is positive integer, remember, n is a positive integer. You know, positive integer means 1, 2, 3, 4, and so on. Now, we are saying that what will be T power n? What can you say about T power n? This is actually quite simple. You know that odd multiplied by odd is odd. Do you agree? Odd multiplied by odd is odd. This we already know. This we have already seen. The proof also we have seen. Odd multiplied by odd is odd. The same thing you have to apply here. For example, if you put n equal to, let's assume if you put n equal to 4, then what it means? It means T power 4. T power 4 means T, 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 T. Now you can see that this will be odd because odd multiplied by odd is odd. T is odd, so this will be odd. Now finally what you have? Now you have odd multiplied by odd multiplied by odd. And what you can do? Again, you can see that this will be odd. Again, you can easily see that odd multiplied by odd. Again, this will be odd. Again, finally, this also will be odd. So whatever you do, you will get an odd value. You are going to get an odd value. Okay. So Aditi is asking, can you explain P power n divides A power n again? So Aditi, did you understand in the previous question, did you understand that P divides A? So far, is it clear that P divides A? Let me know. P divides A, is that clear? P from the Euclid lemma, so far is it clear? Okay, if it is clear so far, see, P divides A, if that is clear, then you can easily see P divides A. What this means? Can I say that if P divides A, then this value will be some integer? Some integer? Can I say? P divides A, so this value will be some integer. When you divide A by P, then some integer you will get. Now you can easily see that what is A power n? Now let's see what is A power n divided by P power n. That is like A by P, A by P, A by P, and so on, A by P. Now you can easily see this is integer. This is also K. This is also K. This is also K. This is also K. So finally, A power n divided by P power n, that is K power n. Integer multiplied by integer multiplied by integer. You know this is integer. You know this is integer. Integer multiplied by integer multiplied by integer. So that is an integer. Okay. So A power n divided by P power n, that is integer. And so you can easily see from here what you can say. Now you can easily say that P power n divides A power n. Clear? Is this clear to everyone now? If someone had any doubt, is this clear to everyone now? Okay, this is your statement. Very easily you can see. Now, this question also we have seen, very simple, that odd multiplied by, you can multiply basically odd power, any power if you put, any power if you put, that is like integer power. Sorry, if you put positive integer power, this is z positive integer. So odd power any positive integer, that will be odd. Okay, that is going to be odd. Correct. Very simple. Actually, if you notice, what is this? Tell me. This type of proof, what this is called? Like I am taking n equal to 4 and I am doing this odd. This will become odd, then this will become odd, then this will become odd. What this proof is? Can anyone tell me? Can anyone tell me what this proof is? Like first I'm doing this odd, then this will become odd, then this will become odd. This proof technique. What is this proof technique? Can anyone tell me? This is induction. Very good. Very good. Very good. This is induction actually. So let's try the induction. Actually, this is induction. You can prove it by induction. Easily you can prove. Let's prove it by induction. Let's try this by induction. I am just giving you one example. I am giving you where I will prove this question by induction. Is this clear? See what I'm going to do. This result you already know, that odd multiplied by odd is odd. This result you already know. Okay, this we already know. Now let's see. Now let's prove that if t is odd, okay, if t is odd, then what can you say about t power n? Then t power n is also odd. This is what I will prove. Okay, if t is odd, then t power n will be odd. This is what I need to prove. Okay, this is what I need to prove by induction. So what I will do? What is the base case? Let me know. What is the base case? I want to prove that. What is the base case? And you know that n is a positive integer. This you already know. This you already know that n is a positive integer. N is a positive integer. So what is the base case? You can easily create the base case. The base case is when n is 1. When n is 1, then the base case is correct. T power 1, that is odd power 1, that is odd. So base case is okay. Base case is done. Agree? Base case is done. We have established the base case. Now which part will come? After the base case, what will come? Now our assumption will come. Correct? Now inductive hypothesis will come. Inductive hypothesis will come. Our assumption will come. Now for induction, let's assume that till n it is correct. Okay, let's assume that till n equal to k it is correct. Okay, so let's assume. Now our assumption will come. Just assume for a moment. Let's assume that. Okay, for n less than equal to k it is correct. Or I can say for n equal to k it is correct. No problem. Let's assume for n equal to k or less than equal to k. Basically till k we have proven it. Let's assume we have proven it till k. Okay, either you can say this less than equal to k, or you can say equal to k. Both are correct. There is no problem. So let's assume that till n less than equal to k you have proven it. This is what I'm assuming. Assume that for n less than equal to k we have this thing. What we have? We have a power n is equal to odd. Sorry, t power n is equal to odd. We have proven it. Like as long as if n is less than equal to k, then I'm assuming that a power n, sorry, t power n is odd. I'm assuming that I have proven it. I'm assuming I have proven it. This is what I'm assuming. Okay. Now what is the next step? Now we will prove for n plus 1. Now we are going to prove for k equal to, or sorry, n equal to k plus 1. Okay, now we are going to prove for n equal to k plus 1. When n is k plus 1. For this we are going to prove. So I hope this point is clear. So you can notice that t power k is odd. This we have assumed that t power k is odd. Now we are going to prove that if n is equal to k plus 1, then what will happen? See what will happen. T power n, that is t power k plus 1, that is nothing but t power k multiplied by t. Now this we already have assumed that this is odd. We have already assumed this is odd. This is already odd. Odd multiplied by odd is odd, and that's it. Hence proved. Hence proved that this is odd. Hence proved that this is a odd. That's it. This is your proof by induction. Hence proved. These things are interesting, right? Like these things, these small things are very interesting if you think about it. Like you will find these things very interesting. These small things you are proving. You are not by hearting. You are proving these things. Okay, so definitely you will find them interesting. Anyway, so this is how you can prove. Similarly, can you prove this also by induction? This last statement, so you can see this is correct. This last statement also, can I give you as a homework, like prove by induction? Prove by induction. So you can prove by induction also. Okay, so there are many ways to prove the same thing. Abhay, the same concept, the same thing you can prove in many different ways. Is this clear? I think you have uploaded your proof on the GateOverflow website in the comments, and that is correct. Okay, so if you have any different proof, you can write it and you can upload in the comments, or you can write an answer on this question. The point is simple, that same question, same theorem, we can prove in many different ways. And this is also very easy. Even power anything that is even. Okay, so if you do even power anything that is even. So the fourth statement is even power n, where n is a positive integer. Okay, so even power n is even, and this is also very easily you can prove, because it will be like even multiplied by even multiplied by even. It's like even multiplied by even multiplied by even. How many times? N times. Correct? How many times? N times. N times you are writing. Okay, n times you are writing this even. This even you are writing n times. Now you can easily see that what will happen. See, this will be even. Once this is even, then what will happen? Then this will be even. And so on, if you keep doing like this, and so on, if you keep doing like this, then finally also it will be even. You just keep doing like this, then finally this also will be even. So even multiplied by even, and so on. Okay, very easily you can do. Very easily. So this question is clear to everyone. How many of you did it correct? This is a simple question actually, very simple. And in this question, the answer will be BCD. So the answer is going to be, for this question, the answer is going to be BCD. Abhed is asking, sir, if we are not able to think about counter example, then how we proceed? Abhed, it's actually, as I told you, that proving something is not a easy thing. Okay, so that is the reason proof techniques are not in the GATE syllabus. In the GATE exam, they are not going to ask you these questions. Okay, of course, if you do a lot of practice, then you can with a lot of practice, I told you, practice plus experience plus luck. Okay, many things must happen together, then you can prove something. See, these are simple statements. You can understand them. Once I explain, then you can easily understand, right? But I told you my example, or many examples. There are people who work on one problem for 5 years, 10 years, on one problem, on a single problem. Mathematicians, actually, on a single problem, all the mathematicians in this world, they are working. Okay, I told you many conjectures are there, many open problems are there. On those open problems, all the mathematicians of this world, they are working for the last 60 years, 70 years, for last 100 years. Still people are not able to prove it. Neither people are able to prove it, nor people are able to disprove it. So these things are not easy. I am not saying that these things are easy. I am saying that, did you understand? Once I gave you the explanation, did you understand? Once you saw the solution, once you have done the analysis, did you understand? During the exam, when you are attempting the weekly quiz, at that time, if you are not able to solve this question, that is fine. Please understand. If you did not solve this question, if you did not get the correct answer for this question during the exam, then that is correct. That is fine. That is okay. Okay. But now did you understand that this option A is wrong? And the counter example we have seen. Did you understand the counter example? Did you understand that B is true? Did you understand C comma D is true? This is our purpose. Okay. The same thing I have told many times, that our purpose is improvement. This is a simple question, and the hint is also given to you in this question. If you see, consider the following statements. For every integer, we have to prove that this is odd. For every integer, we have to prove that this is even. This is actually a simple question. You can prove it. How will you prove it? Actually, the hint is also given, that n is either odd or even. See, one thing I want to tell you here. Let me, this I will give you as a homework. You can do it yourself. But let me do this. This I will do. Okay, let me do. See what is happening here. If you look at this statement 1, if you apply the direct proof, then you will get stuck. Okay, what this means, that if n belongs to integer, if n is any integer, for all integers we are saying that this will be odd. 5n square plus 3n plus 7 is odd. Okay, if you do the direct proof, then you will get stuck. Do you agree? Like what you will think, okay, let me prove, assume this for contradiction. Okay, for contradiction. No, for contradiction. Like if for contradiction, if you assume, if you do the contradiction proof, then you will get stuck. For contradiction, what you will assume? You will assume that for contradiction, this is not correct. For some integer, you will assume that for some integer, this is what you will assume. For some integer n equal to k, this is not true. Okay, this is not true. Means 5n is for some integer. Please understand that for contradiction, this is what you are assuming. That let's assume for contradiction, for some integer n equal to k, 5k square plus 3k plus 7 is even. Now what you will do? From here, what you will do? You will do this. 5k square plus 3k plus 7 is equal to twice 2a plus 2a. Okay, that is even. Even means 2a. Now you are stuck. Now you cannot go anywhere. You cannot go anywhere, right? At this point, you are stuck. Now you cannot go anywhere. Very simple. Okay, so this is what I'm saying, that in this you will get stuck. But the question is actually, the hint is also given to you in this question. Hint is n is either even or odd. See, for all integers we want to prove. N can be any integer, and we want to prove that for all integers this will happen. For all integers. So if you have all the integers, then either this n will be even, you prove when n is even, or you prove when n is odd. Only these are the two things you have to do. When n is even, you prove that this will be odd. And when n is odd, you prove that this will be odd. So in this situation also this will happen. In this situation also this will happen. Then I can say that for all these things it will happen. That's it. This is what you have to prove. Okay. I think now this is very easy. I will not solve it completely, but I am telling you that you can create two cases, because you know that every integer is either odd or even. Only two cases are possible. N is an integer. Every integer is either odd or even. So either this case will be happen or this case will happen. Only two cases are possible. Or either this case will be possible or this case will be possible. Only two cases possible. In these two cases, you can prove that this is correct. In this case also, in this case also, in both the cases, this is correct. Then you can say that for all integers, this is correct. So you can prove it. The hint is also given to you. You can check it out. Let's move on. This is another question actually. By the number of views, you can see that many students have doubt in this. See, on this question, there are 44 views, but on this question, there are 103 views. It tells you that on this question, in this question, many students have doubt. Did you do this correctly? This was actually very simple question. Let's see what this question was. Let's look at S1. Look at S1. Given any real number, R means, this means real number. This is the real number. Okay, so given any real number, there exists, given any real number, whatever real number you take, there exists an element which is real such that xy equal to 1. Is this correct? Like for every real number, can I say, for example, if you take, let's look at this S1. This S1 is saying that for all real numbers, for all x belonging to R real number, what happens? There is some, there exists, for everyone there exists some real number y such that xy is equal to 1. Now, if you think about it, what will happen? For all real numbers, there is someone such that xy will be equal to 1. Now, you can see that, for example, if you take x equal to 2, then what will be y? If you take x equal to 2, then what will be y? Y will be 1 by 2. Okay. Similarly, if you take x equal to minus 3.2, what will be y? Y will be minus 1 divided by 3.2. So basically, whatever x you take, what will be y? Y will be 1 by x. Correct? Yes or no? So whatever x you take, then y will be 1 by x. You can see. But there is one problem here. What is that? There is one problem here. The problem is that, what about 0? See, whenever you see this type of thing, you should, in your mind, 0 should come. Don't you think? Don't you think that whenever you see this type of thing, in your mind, 0 should definitely come? Do you agree? In your mind, 0 should definitely come. Whenever you see this type of structure, 0 should definitely come. So you can notice that, what about 0? But there is a problem. What is the problem? The problem is, what about x is equal 0? What if x is 0? Now you can see that if you take x equal to 0, do you have any real number such that xy will be 1? Is there any y? Let me know. Is there any y? When x is 0, is there any y such that this will happen? The answer is no. The answer is no. Okay. So simple. This is a simple question. And the answer will be that S1 will be false. So this S1 is basically false. Okay. What about this S2? What about this S2? There exist. Again, the question is saying there exist two irrational numbers. Actually, this S2 is a gate question. Let me tell you. This S2, this is actually a gate question. This is GATE 2001 question. Let me tell you. Clear? So I told you that in the GATE exam, these questions can come. Whatever we have seen in the proof technique, some questions can come in the GATE exam. Do you agree? In aptitude, they can come. In some other, some of these questions can come in the GATE exam. Remember, these things are not like completely unnecessary. Some questions, we have seen so many questions. We have seen so many, I can say, proof techniques. Some of these questions can come in the aptitude. Okay. So anyway, this is your GATE 2001 question. So what this is saying? This is saying that there exist two irrational number such that their addition will be rational. Yeah, that is correct. That is correct. Like, for example, your S2 is saying, can you give me two irrational number? S2 is saying there exist irrational. There exist irrational A, B such that A plus B is rational. That is actually correct. Yes, there exist. What you can do? You can take this, like A you can take as square root 2. B you can take as minus square root 2. Okay, so you can take this, or you can take this. See, here I am taking one positive number, one negative number. Can I take two positive numbers and can I make this? Can I take two positive numbers and make this? Can I take two positive numbers and make this? Yes, of course. You can also do this. For example, you can do 10 plus square root of 2, and you can take 10 minus square root of 2. Again, you can see that this also will work. This is also going to work. This is also going to work. Very simple. So in this question, S2 is actually true. So answer will be only S2 is true. Clear? Simple question. Now something interesting actually I want to tell you that will, I think that will come here. Oh yeah, right. So take this question. Something interesting I want to tell you. What do you think about this one? Like one question I'm asking. Let me ask you. This is my question. This is my question one. What can you say about rational plus irrational? Can it be rational? What can you say about rational plus irrational? Can it be rational? Is it possible it can be rational? It can never be rational. Why? How will you prove it? Rational plus irrational. This can never be. This can never be rational. How will you prove it? You can prove it by contradiction. By contradiction, you can prove. So by contradiction, you can easily prove. What you will do for contradiction, what you are going to do? You are going to assume that, let's assume rational plus irrational is rational. Assume. Okay, for contradiction, let's assume. This is what I am doing for contradiction. Assume you have rational plus irrational is equal to rational. Okay, rational plus irrational is equal to rational. So this rational means what? This rational means some A by B, where B is not 0. Correct? Where B is not 0. And this is rational. It means this is like C by D, where D is not 0. So from automatically what will happen? Can you see now? There is a contradiction now. Now there will be a contradiction. See, we are saying that rational plus irrational is equal to rational. Now you can easily see this irrational will be also rational. Okay, this irrational will be equal to C by D minus A by B. And that is like BD CB minus AD. You know that this is not 0. You know this is not 0. And you know this is integer. All are integer. This is integer. This is integer. So there is a contradiction or not? There is a contradiction or not? Okay, so there is a contradiction. Irrational is equal to, so there is a contradiction. What is the contradiction? We have a contradiction, and that contradiction is like this. That contradiction is like this, that irrational is equal to integer divided by integer. This is a contradiction. Okay, clear? Very simple. Very simple thing, that this is your proof. So you can see that these things you can easily see. What about rational multiplied by irrational? Second question I am asking. What about this, like rational multiplied by irrational? What can you say about it? Rational multiplied by irrational. Can it be rational? Can you give me some example where it will be rational? Can it be rational? Is it possible? I am asking, is it possible? My question is it possible? Of course, this is not correct. See, of course, this is not correct. But is this possible? My question is this possible? Please understand this question. My question is this possible? Is it possible? Yes, this is possible. Is this possible? And answer is yes, this is possible if you take this 0. If you take this RAT as 0. If you take this rational as 0. Okay, so these small things, right? In this question also, some students can make mistake, correct? In this question also, some students can definitely make mistake. It is a good thing that I did not give this question in the exam, in the weekly quiz. You can see that this statement is false. Please understand that this statement is actually false. But it does not mean that it is never true. See, this statement is false. This statement is false, but this is true when this RAT is 0. This is true when this RAT is 0. Okay. If this RAT is not 0, if I say that this is non-zero, now can I say, now what can you say? If this is non-zero, then this can never happen. If this is non-zero, please understand, if this is non-zero, then this can never happen. Now it can never happen. Now it can never happen. If this is non-zero, if this RAT is non-zero, then now this can never happen. Why? Now you can easily see. Now I can say that. So you can take this as a note, or maybe question that, for example, if A is rational, let's assume A is non-zero rational. It is non-zero, rational. And let's assume B is irrational. Now you can easily see that AB will definitely be irrational. Can you prove it? Can you prove it? Yes, you can prove it by contradiction. You can again prove it by contradiction. Okay, so you can very easily prove by contradiction. You can again prove this question by contradiction. For contradiction, what you will do? Again, you can notice this is rational. This A is rational. So I can say, for example, M divided by N multiplied by irrational is equal to, if you assume this is rational, then it's like P divided by Q. So from here, contradiction will come. From here, contradiction is going to come. Contradiction will happen. So simple things actually, if you notice. All these things are simple. Okay. So many simple results actually you can create. If you want, you can create many these type of simple results. What about irrational plus irrational? What about this? Can I say irrational plus irrational? This, remember, may or may not be rational. Remember, because we have already seen this example that this may or may not be rational. This may be rational, remember. This may or may not be rational. We have already seen the example. Okay. So anyway, so let's see this question. Which of them is true? This is question number 6. So this is statement B. If A, B are real numbers such that the product is irrational number, then one of them is irrational number. What about this? What about this? If A, B are real numbers such that the product is irrational, then at least one of them must be irrational. Yes, this is correct. You can prove by contradiction. Okay, because if both are rational, then the product also will be rational, correct? If both are rational, then definitely product will be rational. This you already know. For example, this is option B. You can easily see that if both are rational, like rational multiplied by rational, that always will be rational. So you can notice that if result is irrational, So from here I can say that if AB is irrational, then at least one of them must be irrational. If AB is irrational, then A or B must be irrational. Simple. Very, 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 very simple. So this statement is correct. What about this statement? If x comma b are two integers such that product is odd, then both are odd. This is also correct. We have already seen. Okay. Very simple. Now, similarly, what about irrational multiplied by irrational? Irrational multiplied by irrational. That may be rational. That may be rational. Okay. See, irrational multiplied by irrational. That may be rational. You can consider like 1 by square root 2 multiplied by square root 2. Or maybe, yeah, sorry, square root 2 multiplied by square root 2. Very simple. Square root 2 multiplied by square root 2. Okay. So that may be rational. Okay, let's see this one. For any integer, if m square is even, then m is even. This also we have seen. The sum of rational and irrational is irrational. The sum of rational and irrational is irrational. That is correct. We have seen. So your answer is what? Okay, your answer will be what? So which of them is true? Answer will be A, B, C, D. Okay, simple. A, B, C, D. Let's move on. This question is another simple question. Do you have any doubt in this question? Anyone has any doubt in this question? I think this is very simple question. Okay. All you have to do is just apply the concepts that you know. Apply all the concepts that you know. So this is a simple question. Let's move on. What about this one? Anyone has any doubt in this? If A plus B is even, then this will be even. This is also very easy. If anyone has any doubt in these questions, you let me know. I will solve them. Else we will move on. Is there anyone who has doubt in this question? Let's see this one. In this question, anyone has any doubt? Another very simple question. By contrapositive, you can prove. In this question, you can apply what concept you will apply? Tell me. Which proof technique you will apply? Contraposition. Proof by contraposition, indirect proof. You can do that. Let's see this one. Anyone has any doubt in this? If any integer A is even, then this will be odd. Again, very simple question. Okay, this is also not very complicated. This is also very simple. Okay, that's it. Some students is asking parity question. Where is the parity question? Okay, I did not take the, this is the parity question. Okay. In this question, someone has doubt. In this question number 10, parity. See, this is already given. Parity means, same parity means two integers have same parity. That is already given. The definition is given. Please understand. Two integers have the same parity if they are both even or both odd. Either both even or both odd. Otherwise, they have opposite parity. That is given to you. Like they have same parity. See, in this question, every information is given to you. The question is saying that you have two integers. You have integers A, B. When can you say they have same parity? These two integers, when can I say that they have same parity? They have same parity if both odd or both even. Either they are both odd or they are both even. Either both odd or both even. And when can you say they have opposite parity? Opposite parity. That means one even, one odd. One even, one of them is even, and one of them is odd. This is your question. Now let's see which statement is true. If two integers have same parity, their summation will be odd. If two integers have same parity, their summation will be odd. No. Actually, if you have same parity, their summation will be even. See, if you have same parity, then your summation will be even. See this. If you have same parity, then summation will be even. So this is your option A. This is the option A. See, definition is given. Aryan, in this question, information is given. You have to use this information. Did you not understand the first line? During the weekly quiz in the exam, did you not understand the first line? The first line is saying that the definition is given to you. Two integers. Read this. Read this now and tell me, is this a simple to understand or not? Read this now. Two integers. The question is saying two integers have same parity if both are even or both are odd. Otherwise, they have opposite parity. Okay, let's see. If two integers have opposite parity, their summation is odd. This is correct. We know odd plus even is odd. This is correct. What about this? What about these two? If n is odd, then 8 divides n square minus 1. If n is odd, let's see this one. Let's see the option C. If n is odd, then 8 divides n square minus 1. You can use the direct proof. You can directly prove it. See, if n is odd, what it means? It means n is equal to 2k plus 1. Now what will be? So tell me what will be n square minus 1? That will be, I can say 4k square plus 4k. Right? So it will be 4k square plus 4k. This is your n square plus 1. Now, one more thing you can see. This is like 4. You take 4 out, you take 4k out, and k plus 1. These are consecutive or not? Tell me, these are consecutive or not? Let me know. K plus 1. These are consecutive or not? Yes, they are consecutive. So if they are consecutive, can I say one of them is even? See, they are consecutive. This and this, they are consecutive. If they are consecutive, one of them is even, one of them is odd. Definitely one of them is even, one of them is odd. So can I say this complete thing is even? Can I say this complete thing is even? Can I say this multiplication is even? Because you know, even multiplied by anything is even. Even multiplied by any integer is even. This we already know. Now this is a cakewalk. So this is even. Even means 2m. 2m. So now this is a cakewalk. Now this will be like 4 multiplied by 2m. That's it. And you can see this is divisible by 8. Correct? Where m is an integer. You can easily see this is divisible by 8. Correct? Divisible by 8. Is this clear? Let me know. Let me know. Is this clear to everyone? Some students who were asking this question, is this clear? Manasa is saying that, sir, can we say that odd minus odd is even? Yes, odd minus odd is even. And even divisible by 8. Why even is divisible by 8? Can I say even is divisible by 8? Is this statement correct that even number is divisible by 8? This is an even number. Is this divisible by 8? This is even number. Is this divisible by 8? No, this is not divisible by 8. This is even number. Is this divisible by 8? No. This is divisible by 8? No. These numbers are not divisible by 8. Manasa, is this clear? Let me know. See, did you understand this proof? This simple proof, did you understand that? See, this is the direct proof. N is odd. N is odd means n is 2k plus 1. If n is 2k plus 1, then what is n square minus 1? N square minus 1 will be this. Now you can easily see these are consecutive, k plus 1. These are consecutive. So one of them is even. One of them is even. Even multiplied by anything is even. So this number is even. If this is even, then this is 2m. Simple, simple things. What about the next? Suppose AB are integers. If AB is odd, then a square plus b square is even. Yeah, that is correct. Because if AB is odd, then both are odd. Right? If AB is odd, then both are odd. Then both are odd. Both A, B are odd. See this option D. Option D is saying that A, B are integers. And we are saying that if AB is odd, then what can you say about A square plus B square? So you can see if AB is odd, then from that you can say that both A, B are odd. Means this is also odd. Both are odd. Both A, B are odd. You know that odd square is odd. Odd square, that is odd. That we already know. So you can see this will be odd square. This is odd. This is odd. Odd plus odd is even. So this is your statement. Now you can easily see answer will be BCD. So this is your quiz. This was your weekly quiz. Any question in which you have doubt and I did not take? See, this is easy question. Do you have doubt? Question number 1, do you have doubt? Question number 2, any question do you have doubt? I can see your chat. Please tell me in which question you have doubt. Don't keep any doubt. This was a good quiz. You don't have to get complete marks. Those students who are getting demotivated because of low marks, please don't get demotivated. Okay. The purpose of weekly quiz is not to get full marks. See, consider the difference between two students. One student who is getting 15 marks and one student who is getting 10 marks. Can you tell me who will improve from this quiz? After this quiz, who will improve? The student who has 10 marks, they will improve. Please understand. Your purpose is improvement. Your purpose is not to be in the top position always. You will go to the top position with improvement. Okay. Constant improvement. Consistently, if you improve, with every weekly quiz, if you improve, then you will automatically go to the top position. Okay. Please understand. Getting the top rank, getting full marks is not the target. Understanding the questions, understanding the analysis, understanding the solution, improving your knowledge, improving your problem solving skills, that is the target. Please understand. Okay. So someone is asking, so let's see. Can you explain question 3 S1? Question 3 S1. Okay. So let's see. Where is question 3? This is question 3. S1 you are asking in this. See, this is S1. Okay. Hers is asking, right? Okay. So see, hers. Suppose A, B are integers. If this is odd, then both are odd. So what is the best way to solve this question? Let me know. Anyone? What is the best way to solve S1? If this is odd, then both are odd. What is the best way to solve this question? Contrapositive? Yes, many students are saying contrapositive. So yes, that is the best way to solve this question. The question is saying that A, B are integers. These are integers. And A square multiplied by B square minus 2B. This is odd. If this is odd, then both odd. Then both A, B are odd. So let's see. You can easily prove by contraposition. Let's apply the contraposition. So tell me, if you apply the contraposition, what you will do? There are two cases. Contraposition. In the contraposition, you will assume, you will basically start with A or B is even. A or B is even, correct? A or B is even, right? You will start with A or B is even. So now you will create two cases. Now there are two cases possible. Either A is even, I don't care about B, or B is even, I don't care about A. Now tell me, when both are even, is that case considered? When both are even, is that case considered? When both are even, is that case considered? Let me tell you. Let me know. Yes, that is considered. I am saying A is even. I am not saying anything about B. Biswanath, is this clear? I am saying A is even. I am not saying anything about B. B can be anything. I am saying B is even. A can be anything. So now let me know. A comma B both are even. Is that case considered? A comma B both are even. Is that case considered? Yes, that case is considered. Okay. Now you see, if B is even, then easily you can see this will be even, right? If B is even, then what you can say about, this? If B is even, then definitely this will be even, correct? See, if B is even, this is even. If B is even, then definitely this whole thing will be even. Even multiplied by any integer is even, remember. Even multiplied by any integer, that is even. Okay. So very simple. And what about in this case, when A is even? That is also very simple. That is also very simple. So if A is even, then the whole thing will be even. So I can say that if A or B is even, then this will be even. That is your proof by contraposition. Yes or no? That is proof by contraposition. Aryan, I have taken by cases. I have done the question by cases, right? Two cases I have created. In this case also, in both the cases, you can notice our proof is done. Our proof is done. Okay. Let me know. Hers, is your doubt clear? The contraposition I am doing. See, I am just applying the proof by contraposition. Proof by contrapositive. Any other doubt? Hers? Let me know. Any other doubt? Anyone has any other doubt? Please let me know. Don't keep any doubt. It is for your, I can say it is for your benefit. If you keep your doubt to yourself, then you are, I can say, you are putting yourself at risk. Okay, you are putting yourself at disadvantage. So please don't keep any doubt. Anyone has any other doubt? Let me know. In this quiz, do you have any other doubt? All the questions are clear. The solution is clear. Any question, any doubt, anything, like anything, small point also you can ask. Please don't keep any doubt. Be selfish. If you have doubt, you should ask. Okay. So finally, I am giving you two bonus questions. Now let's see, is this true or false? Let's see. This is true or false? Let me know. This statement, is this true or false? This question was in the homework. Do you agree? This question was there in the homework. See, this statement is actually false. Because in the homework, I was saying that these are, if you check the homework, please check the homework. The homework was saying two positive integers. The homework was saying two positive integers. This is actually false. Why this is false? For example, you can take A equal to 2, B equal to -2. Now you can notice A divides B. You can notice B divides A, but A is not equal to B. Actually, I wanted to put this question in the quiz, And I knew many of you will do this wrong. This question I wanted to put in the weekly quiz. And definitely some of you, many of you would have done this wrong. But now, see, small things matter, right? The same statement is true if you talk about positive integers. The same statement, if you put positive integers, then that is true. And this we have seen in the homework. Okay, if you put the positive integer, then this becomes your homework 2 question. We have seen the video solution. Okay, clear? So this was your extra question that, so this statement, I hope you understood. This is another final question. One more extra question. This is just an interesting result actually. Okay, the reason I have taken this question is because this is something interesting. You will also find this result interesting. Okay. So this is actually an interesting result. I can say this is a interesting result. What is this result? This is saying that prove that every odd integer is a difference of 2 perfect squares. Okay. Is this clear? Perfect square. Yeah, squares means perfect squares. Okay, so yeah, this is perfect squares. 2 squares. That is same. Perfect square, square. Some people just simply say perfect square. You can also simply say square. Okay, anyway. So let's see. Yes, very simple actually. This is interesting. Why? Every odd integer is a difference of 2 perfect squares. And you can prove it, but the proof will be constructive proof. See, you can prove it and the proof will be constructive proof. Constructive means you will actually create this difference. See, this proof is called constructive proof. This proof is called constructive proof. Do you know, I told you that for 1 year we worked on one problem and then finally we created the proof. Do you remember in my MTech? So we were total 4 people. We were working on one problem. For 1 year we worked on it. This is a graph theory problem. After almost 1 year it took, and finally we proved it. Let me tell you, our proof was constructive proof. Constructive proof means what? It means you actually will show this difference. In this constructive proof, you will actually create this difference. Actually create this difference. Constructive proof means you are creating this difference. This difference you will create. Okay, I hope that is cool. Okay, anyway, the word does not matter. The word does not matter. I'm just telling you what is the proof. See, the proof is very simple. When you see the odd number, what comes to your mind? What comes to your mind when you see the odd number? In your mind, 2k plus 1 comes. Okay, 2k plus 1 comes. Now you can easily see that this 2k plus 1 is actually nothing but, think about it, k plus 1 whole square minus k square. What is that? What is this value? K plus 1 whole square minus, okay, I think k plus 1 whole square minus k square. Yeah, this is correct. Okay, so you can check. That's it. This is your proof. Hence proved. This type of proof, what will you call it? Is this direct proof? Will you call it direct proof? No. Does it fall in any category that we have seen so far? This proof, does it fall in any category that you have seen so far? No. This type of proof is called constructive proof. Okay, let me give you one example. Like, for example, in the theory of computation, you will create DFA. Let's assume I give you a language. I give you a language in the theory of computation subject. I give you some language, and I will ask you, is this regular? Is this language regular or not? You will create a DFA. That is called constructive proof. This type of proof is called constructive proof. So this is interesting result, right? Very simple, that basically any odd integer, if you take, this is an odd integer. This is a odd integer. And this you can write as the difference of two squares. You can write it as this minus this. So simple. So very simply, you can see that every odd integer is a difference of two squares. That's it. Okay. And this type of proof, is, I'm just telling you, no one will ask you, don't worry. I'm just telling you that this type of proof is called constructive proof. You are actually creating. Okay. Anyway, don't worry about it. Like, don't think about it. I'm just telling you that many times you will see this type of proof. Many times. Okay. So this is the point. Okay. Any other doubt? Anyone? Shivam is asking, sir, difference of consecutive perfect square only. Yeah, this statement is correct, right? Shivam, this statement is correct. Also, Shivam, we are not saying that some other, maybe this can be difference of some other, but this is like one possibility. Shivam, is this clear? This is one possibility. We are not saying that it will not be difference of any other squares. It may be possible, but this is one possibility. Clear? Shivam, let me know. Twinkle, there is no definition. What is the definition of constructive proof? There is no definition. It's just an idea that I ask you something, and then you just create some, I can say, something you create, and then you prove. Your creation is proving it. Okay, are you getting my point? You create something, and that creation is the proof. First, you construct something, you create something, and that creation is the proof. Okay. Yeah. So anyway, don't worry about it. Don't worry about all these things. So anyway, this is your proof technique. And finally, it is over. In the proof technique, we have seen one weekly quiz, two homework, and two lectures. This is your proof technique. Now let me know. Are you liking the proof technique? In the GATE exam, no one will ask you. Again, I am telling you, no one will ask you in the GATE exam. But these things will improve your problem solving skills. That is very important, because in the GATE exam, some new questions will come. Some 20, 30 new questions will come. And those new questions you can solve using your problem solving skills. This problem solving skills, remember, don't underestimate. This is very important. Have you seen that same teacher is teaching two students? There are two students, A, B. Same teacher is teaching them, but still one student will get more marks, one student will get less marks. This always happens. Where is the difference? The teacher is teaching the same concept. Then where is the difference? The difference is problem solving skills. One student has improved his problem solving skills. So problem solving skills, remember, in one day you cannot improve. In 1 month you cannot improve, but slowly you will improve. In 1 year, you will see the difference. It's like gym. Okay, whenever you work out, then you are thinking that in 1 day I will be fit, but the fitness will take some time. In 1 day, the difference will not show. But after some time, consistently, if you keep improving your problem solving skills, if you keep learning concepts with proof, without rote learning, if you understand the concepts, then automatically in 1 year, you will see the difference in your problem solving skills. So these proof technique we have seen, these are very important for your problem solving skills, for your analytical skills. Some questions can come in the aptitude exam. It is not that no question can come. Many questions that we have seen, some of them can come in the aptitude. Okay, very simple. This is your proof technique, and the fundamental course is completely over. 2 homework, 2 lecture. I am talking about my area. In the fundamental course, I have taken proof technique, 2 lecture, 2 homework, and 1 weekly quiz. This is our completion of proof technique. Now you can forget about it. Whatever you have understood, that is good. Don't do more practice. Very important point I'm telling you. Don't do more practice. What we have seen, that is enough. Okay, is this clear? Don't open the standard books and keep you are doing the practice of proof. Don't do that. Very strong suggestion. Very strong. Don't do more practice of proof technique. Okay, whatever we have done, that is enough. Now you can forget about it and you can enjoy the technical chapters.